Okay, going over some things before your quiz on the prerequisites, the A1 to A3 sections. So there are some things that, looking at your work, that are going badly. So let's take a look at some of those. So first of them, root of a root. Now I'm going to show you once again why this works, and then the shortcut to this. So let's take a look at these. What if I did this in exponential form? Now this would be to the 1/3 power, this would be to the 1/4. So I could rewrite that in steps. This to the 1/4. And now this would be to the 1/3. So that would be all of this to the 1/3. And then power to a power, what do? We multiply those powers. So this would be to the 1/12. And then if I write that in radical form, like this. Now hopefully you can now see the shortcut. I have a 12 there. 3 times 4 is 12. So the faster way to approach that question, and now I've shown you how to do it, why it works, we just write power, radical to a radical, same as power to a power. You multiply the indices. And if there were a larger number in here, I might need to prime factorize. So for example, if I had 12 and maybe this was 13 in here, I need to split that off. Now that's an if, but it wasn't in this case. Alright, next one. Same thing. I had the 64 here, so we'll have to do something with that. This is a 2. So I have 10, because 2 times 5, and 64xy squared. And I just want to check that 64 and make sure that we are not needing to simplify that further, and we don't, because this will give me 2 to the 6th, which is I'm not going to be able to take the 10th root of that. And now this one, this isn't a root of a root, but I'm multiplying 2 roots. Now if the indices were the same, let's say I had square root of 2 times square root of 3, I could get square root of 6. I could just multiply the things on the inside. And that's because the indices are the same. In this case, the indices are different. So I can't do that. But I can switch it to exponential form, like so. And this reduces, so I'll just go ahead and reduce that. And now when I multiply, my bases are the same, so I can add my exponents. So to do that, I'll need a common denominator. So I get my common denominator, and I can go ahead and add those. And I want to make sure, especially if my numerator happens to be larger than my denominator, I'm going to want to switch back to radical form to simplify. But in this case, we're going to be taking the 6th root of x to the 5th, and that doesn't simplify further. That's 6th root. But let's say, for example, I had done all this and I had gotten x to the 7/5. So that would not be the answer. What I need to do is go back to radical form, split that up, and 5th root of x to the 5th is x. So what's going to get you in pre-calculus is not taking questions far enough, getting someplace and thinking, oh gosh, I'm done. In reality, the trick is going to be often is you don't actually have the answer. You have to take that go the extra mile and switch between different forms to simplify as far as possible. So here are the answers to these particular examples. Let's go on. Another problem area, exponents and roots. So when we start mixing up the different rules here, now if I take a look at this, just face value, I'm thinking, oh gosh, I'm done. What else could I do? But by switching to exponential form, I see the further step. Now this is going to be 2/4, which is 1/2. The y I'm talking about became this, which reduces to this part right here, that 1/2. So if I reorganize this a little bit, we hopefully will see what I can do. By switching to exponential form, now I can add my exponents. Now in order to add my exponents, I'm going to need a common denominator. For the x's, that's going to be 4. So multiply that 2 by 4, so I get 8/4. See, when I rename fractions, I need to make sure I multiply top and bottom by the same number. And the y here, our common denominator is a 2. That should be 2. And now I add my exponents. So what you're going to have to do to be successful is really get used to switching between various forms. Now notice that these are in exponential form, and the numerators are larger. In this case, if I were to simplify it, I would end up going back to this version. So we wanted to do the multiplication here and get those combined. So we are in essence doing the opposite of what we did over here, if that makes any sense at all. We wanted to do that multiplication. Same thing here. We want to do this multiplication, and in order to do that, we're going to have to switch to exponential form. And add our exponents. So this is going to be 2/2, and this is going to be 6/2. And then I add my exponents, so I get x to the 3/2, y to the 7/2. But if I were to take this and simplify it, go to radical form, important to see this. Let's just do it so you see what's happening here. I would split that up so I could do the root. And I can root that. And I can root that. And notice I go back to this. So in reality, doing this particular problem, if I'm asked to multiply it, it's not in simplified form. If I simplify it, I end up going back to the beginning. So we don't want to be going in loops infinitely. So make sure you're understanding of what the question is asking. Okay, and this problem right here, I'll erase all this other stuff, is where we really get confused. We have the powers inside of the radical, which is fine. We can, as long as this is the same index, we can go ahead and do the rules of exponents. So we're going to do that, but I just want to make note of this. We can't pull little tricks like I'm about to show you. Notice I just moved that up there. No. Okay, this applies to numerator and denominator. Just by shortening this to make it imply that it's just in the numerator does not change what it actually meant. So we want to be very careful that we actually write it the way it's intended, which is that root applies to numerator and denominator, which means we may need to rationalize. Now, since these indices are the same, we can use our rules of exponents, and the quotient rule is going to tell us that I could subtract the y's and actually do the same thing with the x's. Now, the fourth root of y to the fourth is y, so no problems there. And this is going to be a problem. I need to rationalize. I cannot leave, under no circumstances should we be leaving radicals in our denominators. So I need a perfect 4 here. Right now I have a 1. So I want it to be a 4. Rules of exponents, if I multiply by a x cubed, I'm going to get that. So that's what I'll do. Numerator and denominator. So our answer is y, 4th root x cubed, all over x. Well, why x? Because x to the first times x cubed is x to the 4th, and the 4th root of x to the 4th is just x. So that is the final answer right there. Alright, negatives in exponents in radicals. So negatives, I mean, you know this, that would mean move that down into our denominator, and then its exponent switches. So just because it's a fractional exponent does not change what I do there. So this is going to be x to the 5th y, and I'll switch it to radical form. See, I moved that one up, and I'm going to move this one down. This one's going to be cube root x to the 7th y to the 5th. And now I'm going to try to simplify these. Now I can't use my rules of exponents to do the quotient rule and subtract these exponents because my indices are different. So I'm going to have to use a different method. So I split up that x to the 5th so that it's a perfect root, and I'll split up this denominator so I get x to the 6th x, y to the 3rd y squared. And now I can do my square root up there. And now I'll do my cube root down here. So I get x squared and y, and then cube root xy squared. Now again, I can't just cancel those because these indices are different, but I can cancel those x's completely. I have a y down there. Now I need to rationalize. I cannot leave that down there, that radical. So I'm going to do cube root, and again I want a perfect cube here, so I'm going to do cube root of x squared y, cube root of x squared y, because I have y squared times y is y cubed. And then I guess I'll move over here. Now I'll erase this later. In my numerator I have square root xy times cube root x squared y all over y. And then doing this, I'm going to have, I'll just do it in steps, cube root x cubed y cubed. So I can do that, and I'm going to get x, y, but I have a y already, so y squared. Now this numerator is going to be a problem, but just take a look. We actually did a question like that already. This one. Okay, same thing. I'm going to have to switch. Oops. I'm going to have to switch to exponential form temporarily, just to deal with this. Now I add my exponents. So my common denominator here will be a 6. And for y, I'll also be 6. And I add my exponents. So for the x's, I'm going to get 7 sixths. So x to the 7 sixths, which is going to be this. And the y is also 6 as the index. Okay, but its exponent is going to be different. It's going to be 5. Okay, so I can deal with this little part right here. Split up that x, so I get x to the 6th times x, and the 6th root of x to the 6th is x. So pull that out. And then in my denominator, those x's are going to end up canceling. So we'll cancel those, gone. And this is the answer. Notice all the different steps we had to take for this one question. Lots of steps, lots of extra work. And the trick is switching between radical and exponential form. So if you're still confused, get extra help. Alright, I'm going to erase this part, and let's try this second question. Now, before I get headlong into this, because there is a lot of confusion on even roots versus odd roots. So if I do the square root of -4, or if I do the 4th root of, say, -16. See, these are both even roots. I can't do an even root of a negative, so I need to switch it to I. So I'm going to have square root of 4, and then I have my I. Same thing here, 4th root of 16, and then I have my I for an imaginary, because I is the square root of -1. So I'm dealing with my negative there. Then the square root of that, and the square root of, well, 4th root of that is actually going to also be 2. And then I've accounted for my negative. But now where we're really messing up is when we have odds. Now we can actually do an odd root of a negative. So if I have the cube root of -8, well, we don't need an I, because -2 times -2 times -2 is -8. So those are 3 -2's there. So all I really need to do if I'm taking the odd root of a negative is have my negative on the outside. So if I had cube root of -27, -3. Okay, so just be aware of that. So I am taking a cube root of a negative. I'm not going to need an imaginary or anything like that. I do have a negative exponent here, so I'm going to have to move that down. So we'll take care of that. I'm moving the x to the -5th down. And it's still in a cube root. See, it's a cube root. That cube root does not go away. Now I'm going to further simplify by splitting up that x to the 5th, and that 16, we'll prime factorize that, and that'll be 4 2's, so 2 cubed times 2, y cubed times y, and cube root, and I do have a -2 here. Well, let's just do a positive out, or bring it out right away. Take care of that. Because the cube root, an odd root of a negative, is negative, so I'll just take care of that right away. Alright, so we get -3, 2, -2, y, cube root of 2y, and then in my denominator I have x, cube root, x squared. Now I cannot leave that in my denominator. I need to rationalize, which is getting a lot of you is not rationalizing. Now, well, that should be x to the 1. I need a perfect cube here because it's a cube root. This is a squared, so I'm going to multiply by cube root of x to the 1. That will give me my perfect cube. So, boom. Go over here, -2y, cube root of 2x squared y. Where did I get that? Here's my, oh, nope, not an x squared, x to the 1, sorry. X to the 1, messed that up. All over x. Now, cube root of x cubed is going to be x, and then I already have an x there, so x squared. And then this is the answer to that one. Again, lots of steps. Alright, and the last one. So I don't have any negatives to worry about there. I'll just get rid of all this. Nah, give me lots of room. Okay, so let's go ahead and switch to radical form. And I'll split up that y right away because I see I have a square root. And I'll prime factorize that 8 to this 8, and I'll get 2 cubed. I'll split up that x. Okay, now these are different indices, so I can't cancel any of this, but I can go ahead and do my radical. I can take that square root and I can take this cube root. And all of these, except for that x, were a perfect cube. This. Okay. So I have that left. I see x's are going to cancel. I also see that I need to rationalize. So times cube root x squared. Cube root x squared. That's going to give me this x times this x squared is x cubed, and then the cube root of x cubed is that. So in my denominator I have 2x squared y, and then I have xy up here, square root y, cube root x squared. We'll deal with that momentarily. And these are going to cancel, and those will cancel. So I'll come up here, and I'm going to switch that y to the 1/2, and this cube root x squared to this exponential form, so I can deal with it. Now I canceled one of these x's, and I canceled the y. Those canceled, those canceled. Alright, now I need a common denominator. It's going to be 6. And I see that I get 6th root of x to the 4th, y to the 3rd, all over 2x. And that's my final answer for that one. A lot of steps. Alright, so that was A1. Now some challenges that presented in A2. Powers of binomials. I can't do this. I can't just square this. I can't do 3x squared minus 2 squared and get 9x squared minus 4. I cannot distribute a power. You might think you can. You might think, oh, well, Mr. Kane, if I had this, we did this, 9x to the 4th y squared. But how many terms is in here? This is one term. And I'm not distributing this. I'm doing power to a power. Okay, so that is a lot different than this situation right here. We have more than one term, and it's not power to a power. So I need to use what squared means, and it means something times itself. Now I'm going to multiply this. Remember a trick. First thing times last thing, like this, so I get 9x squared minus 6x, and then this times both of those, so minus 6x plus 4, and I get 9x squared minus 12x plus 4. Right here, it's cubed. Well, what does that mean I'm going to have to do? Yes, I'm going to have to write it out 3 times. Now, later in the year, we'll learn, hopefully, a trick that'll make these longer ones where we have like higher exponents easier than what we're about to do. But for now, I'm going to chunk this. So I'm going to do this part first, and I'm going to leave that, and I'm going to make sure I put my answer in parentheses because I am multiplying. I want to maintain that multiplication. So in the end, I'm going to get x squared plus 6xy plus 9y squared by multiplying all that out. And now I'll take this times both of those. So I'll get x cubed plus 3x squared y. This times both of those plus 6x squared y plus 18xy squared. And then finally the 9. So I'll get plus, I'll just go on to the next line, plus 9xy squared plus 27y cubed. Now I need to combine what I can, so I have my x cubed, alphabetical order, and then the powers of x should decrease, so I'm going to get, these are like terms, so I get 9x squared y, and these are like, so plus 27xy squared. Notice how the powers of x are decreasing and the powers of y are increasing, plus 27y cubed. Okay. Right here, factoring groups. Look, I'll erase this in a moment, but in essence, these two are no different. All right, really, it's the same problem. Whatever's in here, it really doesn't matter. The factoring process is still the same. So, some of you have seen on your work. Does not matter what this is. No matter how complicated it is. Still the same idea. So let's try it. So, big parentheses. That group minus 7. That group plus 7. Now, I can combine these a little bit. 4 minus 7. 4 plus 7. And now I have successfully factored that. Now, if you want, you can expand this thing. X plus 4 times x plus 4 gives me x squared plus 8x plus 16 combine these. See, I took this and then factor that. See, 11 times 3, negative 33, and 11 minus 3, 8. So either way is fine. I think this way is by far easier, just recognizing that this is just a squared group. Same thing here. Now I'm not going to expand this. I'm going to do it this way. So I have 8 minus that group, 8 plus that group. And now I see I have things that I can combine a little bit. So I have 8. I need to distribute that negative. Something I noticed some of you are doing. You're not distributing your negatives all the way. That's a silly mistake. 8 plus. No negative to distribute on the next. And then I just combine whatever like terms I happen to have. Alright, and that's our answer there. Did this one. Alright, so final one right here. Some of us are getting confused because there's an extra y here. Look at how we're doing this. If I had something similar. I don't know. Okay, so when I do a binomial factor here, x times x gives me x squared. Well, what times 6? What two things give me to 6? Well, I could have 2 and 3 or 1 and 6. But that's what we're doing. The factors of 6 right there. So what? There's a y right here. So what? So let's try a few things. Let's try. Now I do have a negative here. So actually what I'm going to do is I'm going to factor out. Oops. I didn't want to do that. So I'm going to factor out a negative right away. Negative. I don't want my lead thing to be negative. So I'm going to switch all these signs to some positives. Oh, that should be a 17. Okay, that's going to be a lot better. Now, I'd factor out the common thing if I could. There is no common thing. So let's try 2 and 3x. If this doesn't work, then I might try 6 and 1. So there are a lot of possibilities. Now, I see 12 here, and I might think, oh, 4 and 3, like this. But then we would see here, 2 and 4, I could factor out a 2, so it's probably not that. So let's try 3 and 4 like this. And now, it's not just 3 and 4, I need a y, okay, because of the y squared. And this, let's see, going across here, that gives me 8 and 9. Okay, 8 and 9. Maybe I messed up a sign somewhere. But 8 and 9 would give me 17. That doesn't look like it's going to work out. But let's see. We need a plus right here. Plus, 8, plus. But then I don't get my minus, so that's not going to work. So, we could have 6 and 2. Let's try that. Maybe I made up a problem that's not factorable. That's completely possible. Now we could pull out a 3 there, so I'm thinking it's probably not this, but let's just see. That gives me 12 and 6. That's not going to help me out. Okay. Well, maybe it is the 6 thing. So let's try that. 6, x, x. And let's try 3 and 4 like this. Okay. 24. Minus 3. That's not going to work out. 24 minus 3. No. So it's not that. What do you know? I probably did one that's not factorable. Let's try 2 and 6. 12, 6. Nope. That's not going to help me out. Well, I probably did one that was not factorable. So let's work backwards, just so that you can see what's going on. So let's say I thought 2 and 3 was going to be it, but maybe not. Let's try what I thought it was. I thought it would be something like that, and let's just say it was plus. Okay, so y's. That's the only difference, is the point I was getting to. So when I multiply, if I were to multiply, like work backwards, I get 6x squared. And then this would be 8x plus 9x, that's 17xy. And then this is 12y squared. So probably when I made up this problem, I lost the sign and messed it up somehow. But that's what I was going for. Okay, and the last section. There are a lot of questions. Okay, this is going a lot longer than I wanted it. All right, so when we're combining, we need a common denominator. So when I do a half plus a third, as you know, our common denominator is 6. And I multiply this numerator by a 3 and this numerator by a 2 and get 5, 6. Easy. So do it down here. It's the same idea. So what's our common denominator? X, y. I multiplied this denominator by y, so I must multiply my numerator also by that y. And like this. And that's out of order, but that's the right idea. Now, for these other two, it's more complicated because look at these denominators. I need to factor first. So I'll factor them. I'll do that quickly. And now I see, well, what's my common denominator? Well, it looks like it's x plus 3, x plus 2, and x minus 5. So now this denominator is missing the x minus 5, so I have to do 2x times x minus 5. And this denominator, watch that negative, is missing the x plus 3. Now at this point I'm not done. I need to go ahead and multiply that out. I'll work up at the top here. So I get 2x squared minus 10x. I'm going to distribute a negative 3, so minus 3x minus 9. And I'll work on this a little bit. 2x squared minus 13x minus 9 all over x plus 3, x plus 2, x minus 5. Now next step, I would try to factor this to see if any of that would cancel with that denominator right there. Alright, I'm going to need a lot of room to do this other one. So I'm going to erase all this. Okay, I'm going to start the same. I'm going to factor. Yes, this factors. Ones. Minus 5. I'm going to switch that to a plus and write the minus up here. I can move that up and switch to a plus. That's fine. And plus 3. Okay, so my common denominator, I have an x minus 1 and an x plus 1 and an x plus 2. Notice I have one of each of them. I don't need the x minus 1 more than once. I see it no more than one time on any of these. Alright, so this fraction was missing the x plus 2, so I'm going to do 2 times x plus 2 minus 5 times this one's missing the x plus 1. See? Missing x plus 1. And this one's missing x minus 1. Now I'm just going to work on the numerator a little bit by distributing, so I'm going to get 2x plus 4 minus, I'm going to take that sign with it, distribute it to everything, and the 3, and combine like terms. Notice, looks like all the x's go away. 4 minus 5 is negative 1, minus 3, negative 4, and then I have my denominator. All the x's canceled. Alright, and the last thing, complex rationals. This fraction bar means to divide. Okay, now some of them get more complicated, and we'll work on that when we start class. But we start the same way. We're going to factor. Nothing to factor in the top part. This means to divide, so I'm going to divide. I'll factor the bottom part. Keep, flip, change to multiplication. Now, could we cancel completely? crossways. 3 and 12. Some of us are forgetting our numerical things that cancel. Our x's will cancel, and one of the y's will cancel, so that'll become a 4. So we get, in our numerator, x plus 1 all over 4y to the 4th. Final answer. This one all looks junky, but it's not that bad. I think I'll erase this part. We'll switch to blue. Patriotic. Okay. So this factors. That one's not that bad to factor. Oh, not squared. Okay, and we're going to divide this by, I can factor that. I do see a problem here. Alright, so I'm going to keep the first fraction. Wasted some time right there. I'm going to flip right away, so I'm going to factor this but put the answer up here. So x plus 3, x minus 3. This does factor. Well, how do I know that is 2x? 2x and x. Because 2x times x is 2x squared. And now I need a 5 here. So the question is, does the 5 go here or here? Well, let's just try right here. Well, I need a 5, so it's going to be a 1. Why am I guessing this? Well, because I'm thinking something's going to cancel here. So that's going to give me 2xy. This will give me 5xy. I need a negative, so this one will be negative. This one will be positive. And now we see what cancels. This. And that question is done. I can't cancel those x and y's independently. They're a group. Alright, that's it. So hopefully that helps you, and now you're done with A1 to A3. Make sure you get your corrections in. Then you have a review worksheet. You do not turn that in. That's for you to practice for your take-home quiz that you must do only with a calculator, no help whatsoever. Good luck.